Welcome to TE Pedagogy Power Ups by Things Education, where you get quick tips or cheat codes to power up your education game.
In today's episode, we'll talk about scientific inquiry. It is an essential approach that fosters active learning and deeper understanding of the world around the students. So, how can we plan a curriculum using scientific inquiry? Let us break it down into 6 key steps. Step 1 is observing a phenomenon. Here, the key question is, what do you see or feel? The purpose of this step is to evoke curiosity, surprise, and wonder among the students. And this can be done by allowing them to observe a interesting and puzzling real-world phenomenon. For example, in a science class where students are performing an experiment where there are 3 bottles, one is completely filled, the second is half filled, and the third is empty, and students get to observe which of these 3 bottles actually float or sink. In non-science classes, getting students to read thought-provoking texts or even empathizing with people who are in certain situations or scenarios can also serve as very powerful observations. The second step is asking questions. We ask the students, what do you think or what do you wonder about the observation? At this point, the students start to formulate possible explanations for the observations that they have done. And in this process, they are thinking about the different components of the phenomenon that they have observed, and they try to make connections with the prior knowledge that they already have. Going back to our earlier example of the science experiment, in this case, students might think or wonder why some of the half-filled bottles sink while some of them float. And this can lead them to start thinking about factors such as mass, density, and volume. The third step is making or building a hypothesis. At this stage, we ask the students, what do you guess? After building connections, students use their understanding to make educated guesses. At this point, it requires both their observation and prior knowledge to make or build this hypothesis. For instance, students might hypothesize that properties like density, mass, and volume are affecting the behavior of bottles inside the water. Now, coming to the next step, which is the fourth step. This step is planning and carrying out investigations. At this point, we ask the students, how do you investigate the phenomenon that you have observed? At this point, students design an experiment to test their hypothesis, and they keep in mind the different variables which are involved in this experiment, or what are the different constants, and what are the different controls that they have to have in the experiment. This is an iterative step, and this step aims towards gathering as much as evidence as possible to test the hypothesis. For example, students might devise a plan or an experiment which tests just the effect of mass on floating or sinking while controlling the volume aspect or volume variable of the experiment. The fifth step would be engaging in arguments from evidence. At this point, we ask the students, how do you know? At this point, the students will have collected the data from the experiments that they devised, and they are organizing all this data and analyzing it to find patterns. Going back to our sinking and floating example, students would have gathered data, organized, analyzed it, and found patterns which would further refine their understanding of the principles which govern buoyancy. The sixth and final step is constructing explanations. The question at this step is, what do you think? This is a very crucial step or stage because it connects the students' previous knowledge, hypothesis, and their evidence. At this point, students present their findings to the teacher or to the class and get feedback which helps in building their new understanding. For instance, in the floating experiment, at this point, students will explain or will be able to explain how density and mass impact whether a bottle, which is half filled, empty, or completely filled, will either sink or float. So these are the 6 steps of scientific inquiry. These 6 steps actually help us to transform a very content-heavy curriculum into a more refined process of teaching through scientific inquiry. The process or approach of scientific inquiry can be a little challenging, but it is very important to know that it enhances students' critical thinking skills and engagement in the learning process, as well as it leads to a deeper understanding of the concepts that are learned through this process or approach.
Thanks for tuning into TE Pedagogy Power Ups. Don't forget to show your support by liking our videos and hitting that subscribe button.